You see my screen now?
Yes, sir.
Yes, sir.
Okay. So we have finished the speed torque characteristics of DC motors, shunt as well as series, under motoring as well as braking conditions. We already know that the DC motor is the preferred motor, or at least was the preferred motor for variable speed drive applications. However, now, because of power electron converters, it is now possible to control the speed of induction motors also easily, because of which they are also gaining popularity in variable speed drives. There are a number of advantages of the induction motor over the DC motor, such as they are simple, more reliable, they have no commutator, so there is no limitation on the power that you can draw from the motor or give to the motor. Also, they are cheaper and much lighter than DC motors. The torque to weight ratio is better as compared to DC motors. Now, what you see on your screen is the equivalent circuit of an induction motor as referred to the stator winding. I think you have studied this in your UG course. Is that correct?
Yes, sir.
Yes, sir.
Yes, sir.
So this is the per phase equivalent circuit. VPH is your applied voltage per phase. I1 is the motor current drawn from the supply. You see a shunt branch that has two components. One is X0, the other is R0. R0 represents your no load loss, whereas X0 represents the magnetizing inductance that is responsible for creating the magnetic field. I0 is your no load current. In case of transformers, the no load current is very small, around 2 to 5% of the full load current. However, in case of induction motors, the no load current is much larger. It is around 30% to 40% of the full load current. The reason being, there is no air gap in the transformer, whereas there is an air gap in the induction motor. So for the flux to pass the air gap, you require much more magnetizing current as compared to the transformer. Okay, after that you have your stator leakage reactance X1, the rotor leakage reactance as referred to the stator, that is X2 dash, the stator resistance R1, and the rotor resistance as referred to the stator, that is R2 dash by S. This is a variable resistance, variable because it depends on the value of slip S. As the speed changes, the value of this resistance changes. This is your rotor current as referred to the stator, that is I2 dash. Okay, I think you know all this already, correct?
Yes, sir.
Okay, this is the equation for slip. The slip S is given by the synchronous speed omega 0 minus the actual speed, that is omega, again divided by the synchronous speed omega 0. The synchronous speed omega 0 is given by 2 pi n0 by 60. Might have used ns earlier. In this book we use n0. Okay, so I'll be following n0. So the synchronous speed omega 0 is given by 2 pi n0 by 60. Now we can substitute n0 is equal to 120 f1 by capital P. That gives us omega 0 is equal to 4 pi f1 by capital P, where capital P is the number of poles. Or it can also be written as 2 pi f1 by small p, where small p is the number of pole pairs. Now from the equivalent circuit, this is the equivalent circuit. So this rotor current referred to the stator I2 dash, that will be equal to the voltage applied divided by the impedance of this under root of the, sorry, it will be the impedance of this branch. Okay, so I2 dash will be equal to VPH divided by the impedance is under root of R1 plus R2 dash by S whole squared plus X1 plus X2 dash whole squared. Now this is the expression for the losses. You must have learned in your UG course that the copper loss in an induction motor is equal to SEG. Do you remember this?
Yes, sir.
Yes, sir.
So this is the copper loss, 3I2 dash squared R2 dash, that is equal to S multiplied by, if you neglect the losses, then the air gap power will be same as the output power. This is torque omega 0. E into omega 0 is the power multiplied by S. So this expression gives us torque is equal to 3I2 dash squared R2 dash divided by omega 0 into S. Now we can substitute I2 dash from here to here. So I2 dash squared will be equal to BPH squared divided by this under root will cancel. If we substitute that here, you get torque is equal to 3 BPH squared R2 dash divided by omega 0 bracket R1 plus R2 dash by S whole squared plus X1 plus X2 dash whole squared multiplied by S. Okay, so this is the expression for the torque of an induction motor. 3 Vth squared R2 dash divided by omega 0 into R1 plus R2 dash by S whole squared plus X1 plus X2 dash whole squared multiplied by S. How many variables do you see in this equation apart from torque? Or on the right hand side, how many variables do you see? Yes, Priya?
Sleep
and speed.
2 variables.
How many variables? 2. Priya, what are those 2 variables?
So, in the torque equation,
This
um,
equation. On the right hand side, how many variables do you see?
input power voltage is variable,
That
and
is input power here,
input voltage means phase voltage.
VPH.
What? Yes, sure. That is the variable, and no loads means no only VPH is the variable.
Okay,
And
anybody else?
slip is also means.
Split is a sir. BPH and split.
So S slip is also a variable. S.
Okay. So at this point, are we able to change the value of the applied voltage?
If it is fixed, so fixed. S is only
At this
variable.
point means, at this point in our syllabus, are we able to change the value of VPH?
No, sir.
So VPH is fixed. VPH is fixed.
Yes,
Means
VPH is
input.
fixed. That means VPH is not a variable. R2 dash is also not a variable. Omega 0 is the synchronous speed. That is also not a variable because we cannot change we still cannot change the frequency, input frequency. R1 is also fixed. So the only variable on the right hand side is the slip S. Okay, clear everyone?
Yes, sir. Yes, sir.
Sir.
So
Yes, sir.
if we differentiate this equation with respect to slip, and why would we differentiate this equation with respect to slip?
Sir, to get maximum torque.
To get maximum
Sir, yes,
torque.
maximum torque.
What is the condition to get maximum torque?
dt by ds equals to 0. dt by ds equal to 0.
dt by ds must be equal to 0. What is the condition for minimum torque?
So we have to put a second derivative to see it is coming positive or negative to get the maximum minimum.
Yes, but the basic condition is same for both. Right? For maximum also dt by ds is equal to 0, and for minimum also dt by ds is equal to 0. Why is it so? The condition is same for both.
So slope
because we
actually
are-
for maximum and minimum
maximum
point,
and minimum
slope is 0.
0.
Slope
Correct.
is 0.
Maximum and minimum
Slope is
slope is 0.
Slope is 0.
Okay. Any general function, if you find out the slope at any point, you will get some value of slope. But at the minimum, the value of slope is 0. Similarly, at the maximum also, the value of the slope is 0. Okay. That is why the condition is same. So if we need to find out the maximum torque, and there are only two variables here, slip and torque. So if we take slip on the x-axis and torque on the y-axis, we'll get the plot of the torque versus speed. Now, if you want to find out the maximum torque, we differentiate torque with respect to slip and equate it to 0. Okay? And then we can get the value of slip at which the maximum torque occurs. Correct? This is not the maximum slip. This is the slip at which the maximum torque occurs, which is denoted by SCR in this book, critical slip. So SCR is equal to plus minus R2 dash divided by under root of R1 squared plus X1 plus X2 dash whole square. Okay, is this clear?
Yes, sir. Yes, sir.
Yes, sir.
So if we substitute this value of S, if we substitute S is equal to SCR in this equation, we get the value of maximum torque. That maximum torque is given by Tmax is equal to 3 dth squared divided by 2 omega 0 bracket R1 plus minus under root of R1 squared plus X1 plus X2 dash whole square. Okay. So we first of all obtained an expression for torque as a function of slip. We differentiated this expression with respect to S, equated it to 0 to obtain the slip at which the maximum torque occurs. That slip came out to be plus minus this function. Okay. And then we substitute this value of slip in this equation to get the maximum torque. 3 dth squared divided by 2 omega 0 R1 plus minus under root of R1 squared plus X1 plus X2 dash whole squared. Anything that strikes you on seeing these equations?
Sir, plus and minus sign.
Plus and minus sign. Okay. So plus sign will be for
Motoring or braking?
plus sign will be for motoring. Negative sign will be for generating. Or braking. Okay. Anything else that strikes you? Yes. Anything else?
Sir, R2 is absent, sir.
R2 is absent where? In the expression for maximum torque,
Absent
R2 is
Absent, sir. Yes, sir.
okay.
The maximum torque is independent of slip.
Rotor resistance.
Who said
Maximum.
this? Maximum torque is independent of slip.
Yes, sir.
Who said this?
Sir, Achilles.
Achilles. So that is the most striking thing. The maximum torque does not depend on the value of slip. Okay. So even if you change R2 dash so that the slip at which maximum torque occurs changes, the maximum torque will not change. Am I clear? If you change the value of R2 dash, the slip at which the maximum torque occurs will change, but the value of the maximum torque will not change. Am I clear? Yes or no?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Suppose this is the value of the maximum torque that we just calculated. Okay. Let us say this is the torque speed characteristic. Okay. You have torque on the y-axis and slip on the x-axis. Okay, so for some value of R2 dash rotor resistance, let us say this is the value of the critical slip and this is the value of the maximum torque. Now suppose you increase the value of R2 dash. So what will happen? Your SCR will increase, but your maximum torque, that remains the same. Okay, it will not change. Okay. Yes.
Yes, sir.
Yes, sir.
Okay, so you have a plus sign and a minus sign. The positive sign is for motoring, the negative sign is for generating. The value of this critical slip and the amplitude or the absolute value of the critical slip is same for both motoring as well as generating. Just the signs are different. Positive for motoring, negative for generating. However, the maximum torque that will be different for motoring as well as generating. Okay. For motoring, you have a plus sign here, so the maximum torque will be slightly less than that for generating. Okay, is this clear?
Yes, sir.
And plus sign for motoring, negative sign for generating. So for motoring, the denominator will be greater as compared to generating. So your maximum torque will be slightly lesser. Now the torque developed by the motor, it is proportional to the square of the voltage applied to it. Okay? So your induction motor is sensitive to fluctuations in the supply voltage. The supply voltage changes, the motor torque also changes. Now from this equation, we can draw the typical induction motor torque speed characteristic. Those typical induction motor torque speed characteristics. These are the typical induction motor torque speed characteristics. You have seen these characteristics before. You have drawn them also. So on the y-axis, we have the torque, and on the x-axis, we have the slip. Slip is increasing in this direction. That means speed is increasing in the opposite direction. Correct?
Yes,
Yes
sir.
or no?
Yes, sir.
Yes, sir.
Slip is increasing in this direction, so speed is increasing in the opposite direction. Okay, so this is the point where the slip is zero. Slip is zero implies that your speed is equal to the synchronous speed. Okay. So when the slip is zero, or when the motor speed is equal to the synchronous speed, the motor torque is also zero. You have seen this in your UG course also, that when the slip is zero, or your rotor speed becomes equal to the synchronous speed, there is no relative speed between the rotor conductors and the stator magnetic field, because of which the induced voltage becomes zero, the rotor current becomes zero, and if the rotor current becomes zero, the motor torque also becomes zero. Correct? So this is that point where the slip is zero and the motor speed is equal to the synchronous speed. This point is your nominal slip and nominal torque, or rated torque and rated slip. Okay. This is the point corresponding to the rated speed and torque. This point corresponds to the slip at which maximum torque occurs, that is SCR, and this is the maximum or stalling torque Tmax. Okay. The M subscript is for motor. Okay, so this is the point at which the maximum torque occurs during motoring. At this point, the slip is 1. The slip is 1 implies that omega 0 minus omega upon omega 0 is equal to 1. This implies that omega is equal to 0, or the speed is 0. So this point corresponds to your starting torque, where the speed is 0 and the slip is 1. Correct?
Yes,
Or
sir.
no?
Yes, sir.
Yes, sir.
So this, I think I missed one equation here. We had these two equations. If we divide T by T max, T divided by T max, that T max has gone up here. So the equation that we get is T is equal to 2 times T max 1 plus A SCR divided by S by CR plus SCR by S plus 2A SCR, where A is the ratio of the stator resistance and the rotor resistance as referred to the stator. Okay.
Sir, SCR means
critical. CR is for critical. SCR means slip at which maximum torque occurs. Yeah, this one. Okay. Yes or no?
okay, sir. Okay, sir.
See, some books they use the notation S max, correct? S max or SM, but that is a misleading notation because this is not the maximum slip. You know? This is the slip at which the maximum torque occurs. In this book, instead of using max or M, he has used SCR, critical. Why critical? Yeah. Why is this the critical slip? Why use critical? Why not use
So,
anything else? SAB, SCD, SFD. Why SCR?
slip. Because after this means motor will after this torque means motor will not sustain that torque.
Yes, correct.
That
This
is
is the
this
maximum of stirring torque. If you increase the
max.
load torque above this value, the motor will not be able to
Means, means
carry
we
that torque. It will stop. Okay? That is why they have used the word critical or CR. Okay? Anything else regarding this equation? Why is
so
Tmax?
means after this a breakdown will occur in the motor. Means this is the maximum torque means which motor can sustain. After this breakdown will occur in the motor.
Yes. And what do you imply by breakdown?
Breakdown means some means permanent fault means will occur in the motor means can possible means after this talk
Okay.
permanent
Okay.
damage means
Permanent
some damage
damage.
can means possible.
The motor cannot handle
Yes sir,
torque beyond that value. The motor cannot handle torque beyond the
means
maximum torque.
some damage can possible means after this talk this is the maximum torque motor can sustain.
Basically, the rotor current will become greater than the rated value beyond this point. If it increase torque beyond this point, the rotor current will increase beyond its permissible value. I think that is the breakdown. That will cause the breakdown. Okay. The torque
Sir,
is equal to
what type of damage will be there, sir? Any winding will burn or anything else, sir?
if the current increases the rated value, your insulation will get damaged. Yeah. Heating. Motor will get overheated. Okay. I'll think about it and let you know in the next class. Okay.
Yes, sir.
Okay. So torque is 2T max 1 plus ASCR divided by S by CR plus SCR by S plus 2A SCR, where A is the ratio of R1 and R2 dash. Okay. So in this equation, if we substitute S is equal to 1, that means at the point of starting, and we get TST or starting torque. Starting torque is equal to 2T max 1 plus ASCR into SCR divided by 1 plus SCR squared into 1 plus 2A. Okay, is this clear?
Yes, sir.
Yes, sir.
Okay, so this is the direction in which the slip is increasing, or this is the direction in which the speed is increasing. Here the speed is 0, the motor is starting here, this is the starting torque, which must of course be greater than the load torque, otherwise your motor will not start. So after this, the motor speed increases, and this is the preferred region of operation of the induction motor, because this region is linear, and more importantly, you get a stable operating point in this region. Okay. If you go on increasing the speed, at this point the motor speed becomes equal to the synchronous speed, in which case the motor torque becomes 0. This is the 0 speed, this is the synchronous speed. Okay. If you increase the speed above the synchronous speed by using some external means, you have to use some external means, then your motor goes into the generating mode. The machine operates as a generator. Is this clear? 0 speed, synchronous speed, greater than synchronous speed. What is this? Here the speed is, here the speed is
0.
here it
Speed is
zero.
decreasing.
Negative.
Yes,
The
here
opposite
the speed
direction.
is
Torque is
negative. That means your motor is running in the opposite direction. You have given a supply so that the motor runs in the forward direction, but your motor is actually running in the opposite direction. When will that happen?
Sir, by reversal of connection, sir.
So by reversion supply.
During braking.
Interchanging the supply terminal.
They're changing the supply terminal. Nahi. This is not that point when you are interchanging the supply terminal. This occurs when your load is an active load, and the load is driving the motor in the opposite direction. Okay. You've given a supply to rotate the motor. Suppose you are using a hoist, and you are applying a supply so that your hoist goes up, but because of the load on the hoist, it is actually coming down. This is that region. This is that region of operation. Okay. Counter current braking. We have seen already in DC motor, counter current braking is possible under two cases. One, when either you reverse the supply, or second, when the load is so high that it causes the motor to rotate in the opposite direction. This region is that region, and your motor is rotated in the opposite direction because of the load. Okay. We'll see this later. Okay. So in this case, if we can neglect the stator resistance, then this A becomes equal to 0. Correct? Yes or no?
Yes, sir.
If we neglect the stator resistance, the value of A becomes equal to 0. And if A becomes 0, torque becomes equal to 2 times Tmax divided by S by SCR plus SCR by S. Very popular equation. Torque is equal to 2 Tmax S by SCR plus SCR by S. Okay. Now based on this, we can approximately draw the speed torque characteristics. Okay. For low values of slip, this S by SCR can be neglected. It does not become 0, but it can be approximated to 0. So for low values of slip, this term can be neglected. So torque becomes equal to 2 Tmax divided by SCR by S, or torque is equal to 2 Tmax into S divided by SCR. Now 2 is constant, Tmax is also constant, and SCR is also constant. If you are not changing the values of the motor parameters. Torque is equal to some constant multiplied by the slip. Correct? Or torque is equal to some constant multiplied by the slip. That is the equation of a straight line passing through the origin. So for low values of slip, the torque speed characteristic can be approximated as a straight line that is passing through the origin. Okay?
Yes, sir.
for higher values of slip, you can neglect the term. For higher values of slip, we can neglect the term SCR by S. This can be approximated as 0. In that case, torque is equal to 2 Tmax into SCR divided by S. 2 Tmax SCR is constant, so torque is proportional to 1 by S. So for higher values of slip, the torque's slip characteristic becomes a hyperbolic function, as you can see here. As the slip increases, the torque decreases. Okay, so in this way, the torque slip characteristic can be approximately drawn from that equation. For lower values of slip, the torque slip characteristic is a straight line passing through the origin, and for higher values of slip, it becomes a hyperbolic function. Okay, any questions here?
No, sir.
No, sir.
Stopping the recording.